Hi, my name is Bailey Groh. I'm a second year mechanical engineering major, and I'm going to be going over chapter 12.3 practice problem number 3. The problem reads as follows. In the gas phase, iodine atoms combine to form I2 in a second order process with a rate constant of 7 times 10 to the ninth at 23 degrees Celsius. If the initial concentration of I is 0.086 molar, calculate the concentration after 2 minutes. Now, the first key part of this problem is to identify it as a kinetics problem, and to notice that it says it is a second order process. The rate law for a second order process looks like this, but for this problem we're not actually going to be considering the rate law because the problem statement states that you want to find a concentration after a period of time. To do this, we're going to be considering the second order integrated rate law, which looks as follows. The left side of this equation has a variable that is the concentration after time t, and that is set equal to the rate constant times time plus 1 over the initial concentration of the substance. Looking at the problem again, we are solving for the concentration after time t, and we actually have all of the variables that we need to solve the right side of the equation. So by simply plugging in the variables, we can solve the problem. When plugging numbers into my equation, I make sure to actually check that the units work out. For this problem, the units of the rate constant are in molarity to the -1 times seconds to the -1, but our time that we are given is in minutes. So, to actually solve the problem, we need to make sure to convert minutes into seconds by using a simple unit conversion. When you actually plug the numbers into your calculator and solve for the concentration at time t, you get that the concentration is 1.19 times 10 to the -12 molar. To actually interpret our answer to this problem, it means that after 2 minutes in this reaction, nearly all of the iodine atoms have combined to form I2. Now let's move on to part B. Part B wants us to calculate the half-life of the reaction when the initial concentration of iodine is 0.6 molar. To solve part B, we want to consider the half-life equation for a second-order process. And that equation is as follows. By looking at this equation, we can instantly see that as the initial concentration of the substance increases, the half-life actually decreases, which means that our answer for part B should be a smaller time than our answer for part C, which will help us in checking our work. Now I'm going to actually go in and plug in our numbers into our equation, and from here on out it is a fairly simple case of just plugging our numbers into our calculator and actually getting our answer out. Our answer for part B comes out to be 2.38 times 10 to the -10 seconds for the half-life if the initial concentration starts at 0.6 molar. Our answer is actually less than a nanosecond, which means that the half-life of this reaction is extremely fast, which is probably to be expected for iodine atoms turning into iodine gas. Next, we can move on to part C of the problem, which is identical to part B, but with a different initial concentration. It reads as follows. Calculate the half-life of the reaction when the initial concentration of iodine is 0.42 molar. We are going to use the same half-life equation because it is still a second order process, and we just have to plug in a new initial concentration of 0.42 molar. By once again plugging these numbers into our calculator, we get an answer of 3.40 times 10 to the -10 seconds, which, as we expected, is a longer period of time than the half-life in part B. Hopefully this video was helpful for you in learning more about second-order reactions and solving for half-lives. Thank you very much for watching, and have a nice day.